Okay, in this lesson, we're going to discover how multiplication and division affects an inequality. So what we're going to start with is we're going to choose two different integers and we're going to put the inequality symbol in between them. So let's go with -2 and 4. And the inequality symbol that we would need to put in between them in order to make the statement true is a less than sign. Now on number 2, it tells us to take each inequality, so -2 is less than 4, and we want to multiply that by -2. So if I multiply this side by 2, and I multiply this side by 2, and we're now going to solve each side. 2 times -2 gives me a -4, and 4 times 2 gives me 8. And when I bring down my inequality symbol, that is still a true statement. -4 is less than 8. That is a true statement. In step 3, it tells us to take the original inequality and multiply each number by a -2 this time. So let's start with our original inequality of -2 less than 4. And we're going to multiply each side by a -2. Multiply it by a -2. And how does that now affect our answer? -2 times a -2 gives us a +4. 4 times a -2 gives us a -8. Is 4 less than -8? No, it's not. That is not a true statement. In number 4, we're now going to take that same inequality again, -2 less than 4, and now we're going to divide each number by 2. Divide by 2, divide by 2. Over here, when I simplify this side, -2 divided by 2 gives me a -1. 4 divided by 2 is 2. When I bring down my inequality sign, is -1 less than 2? It is. That is a true statement. And in number 5, we're now going to divide that inequality now by a -2. So my original inequality is -2 less than 4. Divide by -2, divide by -2. -2 divided by a -2 is 1. 4 divided by a -2 is a -2. And we want to bring down our inequality sign. Is 1 less than -2? 1 is not less than -2. That is not a true statement. So the next question asks us, in steps 3 and 5, what could you do to the inequality symbols to make those statements true? Well, if we come back up here to number 3, is 4 less than -8? It's not. What could we do to make it true? Well, 4 is greater than -8. And in number 5, is 1 less than -2? No, 1 is greater than -2. So what could we do to the inequality symbols to make that statement true? We could flip, we could flip or reverse the inequality symbol. When we go back up to number 3, 4 is greater than -8. And if we go back up to number 5, 1 is greater than -2. So now let's move on to lesson 3.5. When we're solving inequalities using multiplication or division, the property states that if you're multiplying or dividing each side of an equality by a positive number, that produces an equivalent or equal inequality. But if we're multiplying or dividing each side of an inequality by a negative number, we would then need to reverse the direction of the inequality symbol in order for that inequality to be equivalent. Let's take a look at example 1 and see how we would follow those steps. This is showing us m divided by -3 is greater than 3. Remember what I said in the previous lesson. Just because it's an inequality, you're going to solve it the same way we did one-step equations. So the first thing I want you to do is rewrite the inequality. M divided by -3 is going to be greater than 3. And draw our line down showing the 2 halves of this inequality. Now here I gave you the steps of what you need to do. Remember, the same goal is to isolate the variable. In order for us to isolate the variable, we need to get rid of the number that is on the same side. Well, if this is showing divide by -3, we want to do the inverse operation, which is multiply by -3. And then what we do to one side, we want to do to the other side. And when we use the inverse operation, that allows us to cancel out the numbers next to the variable. So what do we now have left? M over here. What do we now have over here is 3 times a -3, which gives us a -9. But what did we multiply by? We multiplied by a negative number. We multiplied by a negative number. And when you multiply by a negative number in an inequality, you have to reverse your inequality symbol. So when I rewrite it, I'm going to reverse it. So this is now my inequality symbol. And that now tells us that m is less than a -9. Now, how would I graph that? Remember, when it's a less than or a greater than sign, we're going to use an open circle. So I'm going to draw my number line. I'm going to put my -9 in the middle. And again, it doesn't matter how many numbers you go up to on your number line. And because it's not a equal to inequality, remember it's an open sign, and m is less than -9. So m can be any number to the left of -9. Let's try example 2, which has us dividing by a negative number. Let's rewrite our inequality. -10t is greater than or equal to 34. I want to isolate my variable by doing the inverse operation. If this is showing multiply by -10, I'm going to divide by -10. And what I do to one side, I need to do to the other. And that now cancels out. I now have left over here t. I now have left over here 34 divided by a -10, which gives me a -3.4. But again, pay attention. Our inequality symbol And what did we do? We divided by a negative. We divided by a negative. So because we divided by a negative number, we need to reverse the direction of our inequality symbol to be less than or equal to. So when we check, or when we create our number line, put -3. And because we have a -3.4, that's almost 3.5. But because it's a less than or equal to symbol, I'm going to use a closed circle. So -3.5 is about here. And it's less than that. So we're going to go to the left. Anything less than goes to the left. And that's how we graph that inequality. What I'd like you to do now is you can pause the video, and I want you to work on your checkpoint, these two inequalities that I want you to solve, and then graph your solution. I'm going to check these tomorrow when you come to school. When you're done, press play, and I'm going to keep going with example 3. In this problem, we're going to take a word problem, and we're going to write an inequality from it, and then we're going to solve the inequality. So this problem tells us that while training for a marathon, you try to consume at least 2,400 calories each day. For one meal, you like to eat at least 500 calories. You choose to eat pasta that has 200 calories per cup. How many cups of pasta should you eat? Well, the first thing we're going to do is identify the variable. We're going to let C represent the number of cups of pasta. And we're going to write an inequality based on the verbal model given below. So we want to figure out how many calories per cup there are, times how many cups we need to eat. And we want that to be more than the total calories, or equal to the total calories for the meal. So based on the word problem, our calories per cup, up here, we have 200 calories per cup. And we're going to multiply that times the number of cups, but we don't know that information, and we're going to let C represent that. And we want that together to be equal to or more than the total calories for the meal. And the calories for the meal is 500. So now we're going to solve that. We're going to write this as an inequality. 200 times C is 200C, and we want that to be greater than or equal to 500. And we're going to isolate our variable, multiplying here, so we're going to divide by 200. We're going to divide by 200. C is greater than or equal to 500 divided by 200 is 2.5. Notice I did not reverse my inequality symbol, and I didn't do that because I am dividing by a positive number. You only reverse it when you are dividing or multiplying by a negative. Now when I take a look at what my solution is, I now want to go back and think, how does that, or what does that solution tell me about this word problem? If C is greater than or equal to 2.5, that means that if you're training for this marathon, you must eat at least 2.5 cups of pasta. And that is it for lesson 3-5. We'll continue with more practice tomorrow in class.